Right, so it's recording. We have got to mark the decimal ones. Okay, so number one, it says you may not use a calculator for this exercise. Write 3,24 as a common fraction. Okay, so we are now on exercise 1 at chapter, I think it's 4, no? Yeah, chapter 4 about the decimal fractions. We're just marking. Remember I handed out that extra page? Okay. Right, so we said we look at the decimals and we have 2 decimals here, which means that I'm going to have to put it over 100. No, so that is going to be 324 over 100. Now, next step would be what can divide into both the top and the bottom so that we can simplify it. And we could divide by 4, both top and bottom. You'll see I'm writing that in yellow, so you don't have to write the divide by 4. Okay? All I need to see is the simplified answer, which is going to be no, this is that small page, that one. Yes. Okay, so it's going to be 81 over 25. So just a quick reminder, can you see the top part is bigger? The numerator is bigger than the denominator. No? Why is that? Because we had 3 comma, and that 3 is like a whole number, so it must be bigger than the denominator itself. Okay, right, let's look at B. Any questions there? Okay, now B1 says write the following in decimal form. Now that was 3 over 40. Okay, now the first step is to get my denominator. Yeah? Yes. Okay, we want either 10 or 100 or 1,000. It depends on what your number was. So over here, I couldn't make it 10. No? Let's rather go for the bigger one. So I'm going to make it 100. So that means, I'm going to multiply with 25. Sorry, this was ignominy. I'm going to multiply with 25 at the top and the bottom. Yes. So which means that's going to be 75 over 1,000. Okay. And that, because it's 1,000, I know that I'm going to have 3 decimal spaces. Now this part is important. I know it's going to be 0, comma, and I'm going to delete it just now. Something, something, something. Can you see 3 spaces? But look at my numerator. I've only got 2 numbers. 0, 0.075. Yes. Okay. So if you've got less than the amount of spaces, then you've got to fill in a 0. Any questions there? Yeah. Yes? Yeah, because 0.75, I'm going to write it here on the side. 0.75 is, okay, if you want to keep it thousands, wait, I haven't even got a mask on. Okay, yes?
If you did it the other way around, like I did that, then I put the thing on.
You said 2.5, yeah, that's fine. Yes, good. Remember, you could make the denominator 100 or 1,000 or even 10. Okay, so it's not wrong. Okay, listen. So if you wanted to still have it over 1,000, then you would have, that. And that is actually 750 over 1,000. So 0.75 is going to be wrong. Okay. Yes, the 0 is a placeholder. Well done. Okay, so let's look at 2. 2 is negative 22 over 9. Please don't forget about the negative. Right? Now, that we're going to say will be negative 2, comma, 4. Unfortunately, this one, we weren't able to get a whole number as my numerator. when I made my denominator 100 or 10 or 1,000 or whatever. Your hand was up just now? With a dot on top. Yes. What she's saying is, remember the negative, and then it would be 2, 4, and instead of writing out 4, 4, 4, 4, 4, 4, 4, you put a little dot on top of that 4 to say that it's a recurring number. It repeats.
We did
Okay.
this in the beginning.
Yes, we did, yeah. All right, so number C. Okay, now C says arrange in ascending order, meaning from small to big. Okay, now that should be minus 3,35, then minus 3,305, sorry, then just minus 3, then 0, and now we're getting to the positive numbers. So 3,15 and 3,4. Any questions there? You guys fine with that? Right, now at D we had to calculate. Oh no, I'm lying. Round off. Sorry. D says round. I'm just gonna write it out. 453,4778. Round that off to the nearest 100. Okay, now where would my 100th be?
In front of the 7.
Meaning there.
Yes.
Okay. Now, if I want to round that number off, then I want to round the second decimal basically. I want to round that off. So then I look at the third decimal, which in this case is a 7, and because it's more than 5, we round it up. So what does it become?
453.
Yes, it's going to be 453, 4, and then 8. Okay. You guys good with that? So any questions? Yes. No, please don't put zeros there. Because they said round off to the 100th. They just want 2 decimal places. Okay. You already rounded it off, right? But so
we don't put a placeholder.
Technically it wouldn't be wrong if you put 0, 0, nee? Maar hulle moet dit mos uitlos, nee? Dit sê rond af tot die naaste 100ste. Ja, so maar as hulle 0, 0, dan ons gaan nie dan die punt enigstens kan gee nie. Nee, want hulle het afgerond tot 100. Ja, okay. Yeah. See, so you can't. All right. Any other questions? Yeah. Okay, now we are skipping to chapter 5, and that is on page 56. So, new chapter. You guys have done this in grade 8 as well, or most of it? Yes. Yeah. Did you do E? I just want to finish the one. Yeah, goeie oefening. I just want to finish Tuesday's one. Okay. All right. So let's start with exponents. So it's a new chapter. I don't know if you want to write at the top of your page. Exponents. And that is on page 56 in your textbook. Okay. So you guys would remember from last year. We've got a few exponential or exponent rules that you have got to study. Right? And if you get those wrong, then everything in your whole sum or equation is going to be wrong. So please make sure that you know these off by heart. Okay, let's just start off with, if I were to give you a to the power of n, that's how we read it. Right? A to the power of n. Now the a, the one over here, we call our base. Do you remember that from last year? Okay, now the n, the one hanging in the air, that is our exponent. Right. Okay. When you read it, you say a to the power. of n. Okay, what's going on at the back? Focus on what's going on the board. Good. Okay, so let's look at the very first rule. Can I skip this page or is someone still writing? Okay, I'll write the law at the bottom. Chapter 5. Okay, so the first law that you have got to know is when my bases are the same and we are multiplying. So meaning I have something like this. A to the power of m times a to the power of, let's make it n. Okay, so can you see my base at both of those is a, right? And we are multiplying. Now, law 1 says that if base is the same when we multiply, what do we do with exponents? We're going to add. Okay, so then that will be, and remember, base will stay the same. So your base was a, it's going to stay a, and then it's going to be to the power of m plus n. No, he's asking, what if I just write mn? Remember, mn, if I write them next to each other, is actually m times n. So that's a whole different, that's the third rule that we're going to do later on. Okay, so remember to put the plus in there. Must be m plus n. Okay, so I want to do a few examples of that. Hands up, we're still copying? Okay, tell me when you've finished. Done.
Is it possible that maybe later on say a to the power of m minus n?
Yes, yeah. That's when we divide. That's law 2. We're going to do that just now. Yeah. Okay, you're done, right? Put the phones away. Okay. Are you still writing? Are you sure? Okay, so let's look at a few examples. X to the power of 2 times x to the power of 3. Okay, base is the same and we're multiplying, so it would be, yes, because we said base will stay the same. And law 1 says I'm going to add my exponents, so I'm going to have x to the power of 5. Okay, let's look at another one. X times, and now listen, minus x to the power of 2. Okay, just to quickly remind you guys about what you've been taught in grade 8. When I put brackets around, it means that that square, or to the power of 2, applies to everything inside that bracket, right? So that minus x to the power of 2 is actually the same as minus x times minus x. Do you guys agree?
Yes, ma'am.
Okay, now a negative times a negative is going to give me what?
A positive.
A positive. And then x times x is going to give me
X squared.
x squared. So what's actually written here is x times x squared. Yes. Yes. Okay, so now from here I can see that my base is the same and we're multiplying. So I must go and add. But this x, although nothing is written there, it's actually a 1. Okay, so technically it's 1 plus 2. Please do not forget about that 1. Just because you don't see it doesn't mean that it's not there. Okay, it's still got an exponent. So if you do tend to forget it, get into the habit of writing that 1. Okay, and that means that my answer will be x to the power of 3. Good. Any questions there? Okay, quickly copy down so I can skip. Guilt. Right, hands up is still copying. Good. Okay, next one. A times B times A to the power of 2 times B to the power of 3. Okay, now, are my bases the same throughout? No. But I can group those that are the same together. Okay, now just in case you sometimes forget, let's fill in those to the power of 1. So A is actually A to the power of 1 and B is just B to the power of 1. Okay, so let's group all the A's together. Okay, so over here, A to the power of 1 and A to the power of 2. I'm also multiplying, so same rules apply. My base will stay A, and then I'm going to say 1 plus 2. Can you see I used A's exponents and added only those? You guys see it? Okay, then times, because now I've got to do the B's, right? I just want to quickly show you guys. You can either write multiply or, oopsie, later on, you could even use a little dot. I remember it was not last year, the year before that. We used the dot in one of the tests, and then the grade 9s got completely confused. They thought it was a comma, a decimal. Okay. A dot is also multiplication. Okay.
So if we use it in one of our sums in a test,
It won't be wrong, no.
if you put it in the middle or somewhere,
Yeah?
does it have to be a
No, put it at the bottom. Okay, now let's group our B's together. So B to the power of 1 times B to the power of 3 will be the same as B to the power of 1 plus 3. So my final answer will be A to the power of 3, B to the power of 4. Any questions there? Good. Last one.
if the bases are the same, you don't calculate them, right? Aren't the same, you don't.
Yeah. Yes. Very important. If bases aren't the same, then I'm not allowed to use this rule. So let's say we have something like A to the power of 3 times B to the power of 2.
And the answer is A, so
It's going to stay exactly the same. Because over here my base is A and over there my base is B. So I can't change anything. The only thing that you could do is you could maybe have written them next to each other. But it's exactly the same thing. Okay, yeah. Yes, you may. Okay, so let's look at the last one. Now I am adding a coefficient. What's a coefficient again? What are? Yes? Not after? In front of? The unknown, yes, or the variable. Good. Okay, so now I'm adding that. So I'm going to say 6m to the power of 2 times 2m to the power of 3. So can you see it's more or less the same as what we just had. The only thing that's different is now I've got a coefficient as well. No. So same rules apply. What is the base at the first one?
6m.
Okay, remember, that 2 is the exponent, and my base will be the m. Okay, base is only 6m if there's brackets around it. Remember, that 2 only applies to the one that's written right in front of it.
Now what is the 6, ma'am?
Sorry?
Now what is the 6?
The 6 is just the coefficient. Yeah. Okay, so, and over here, my base will still be m. So can you see base is the same throughout? And we multiply. Okay, now what do we do with those exponents? With the coefficients? We multiply them. Okay, so this is going to be 6 times 2 gives me 12. And then I use law 1 with my exponents. M to the power of 2 plus 3. So my answer is going to be 12m to the power of 5. Right, so do you guys get law 1? Can we move on to the next one? Okay, now law 2 is basically just the opposite of law 1. At law 2, my bases are the same, but now we're dividing. So previously at law 1, when we multiplied, what did we do with exponents? Add. So now if we divide, we're going to minus, you clever kids, okay?
Will we ever use like minus and then it will be 6m divided by 2m? So how can I say now? Instead of it being now 12m, 2 plus 3, would it be like, say, 8 divided by 2? Will the x
It could be, yes, yeah. Okay, right, so let's write down. Law 2. Oh, I didn't even write it out in words. Did you guys?
Yes, ma'am.
At law 1.
Yes, ma'am.
It's written out in words in the textbook. You'll see that at law 1 it says multiplying powers of the same base. I'm just writing the math part. Eh? Okay, right. Okay, so law 2 says if my base is the same and we divide, what do we do with exponents? We're going to subtract. Okay, so meaning if I've got a to the power of m divided by a to the power of n, I would now say base stays a, but because we're dividing, I am going to subtract my exponents. Do you remember this from last year?
Yes, ma'am.
Huh?
And that's why when they go check now at the back of my book, we did it at the beginning of the year.
Oh, because you remember it. Good. Let's do an example. Oh, another thing is, I'm going to write it here, or. Can you see on the left-hand side, I wrote a to the power of m divided by a to the power of n. So it was written out next to each other. Now, we can just give that same thing, but in another format. I can give it to you in the form of a fraction. So a to the power of m over a to the power of n. Isn't that exactly the same as a to the power of m divided by a to the power of n? No? Yeah. Okay, so when it's in the form of a fraction, you could skip directly to a to the power of m minus n. Or if you're more comfortable with it, first write down that step so you can see it easier. Okay, now the only part that you might go wrong, yeah, yes, right. Okay, remember that when they give it to you in the form of a fraction, we always take the top, meaning the numerator's exponent, minus the denominator's exponent. If you do it the other way around, it's going to be wrong. Okay, so top exponent minus bottom exponent. Even, and we're going to get to that a little later on, even if it gives you a negative answer. Okay, so don't think it's wrong if the numerator's exponent is smaller than the denominator's exponent. Okay, yes. Okay, wait, let me write down. So a to the power of 9, yeah? In a fraction, or do you want me to write it out? Okay, so divide by a to the power of 11. Then I want you to see that bases are the same, and we're dividing. So we're going to say a to the power of 9 minus 11.
So the exponent will only be negative.
Yes, so your exponent is then going to be a to the power of negative 2. You are allowed to get a negative exponent.
Yes, ma'am.
And a little later on in the chapter, I'm going to show you guys how to make a negative exponent a positive again.
Is it answered by the base?
It's going to move.
Oh.
Yeah. Yes. No. The exponent is the negative. Okay. Right. Any other questions here? Okay. Who's still copying? Hands up. All right. Quickly finish. I want to do more examples of this one. Allee, okay. Dis lekker. Waar was die juffrou so lief vir daai kind? What are you doing? No, don't put your mask on. Take your mask off and tell me what you're doing. You can't because your mouth is full. Nee. Say again. Kyk, hy kan nie eens praat nie, so vol is sy mond. Sis vir jou, sharing is caring, né? Right, hands up, we're still copying. So jy mag nie eet. Hierdie juffrou se klas is spotless.
Ja.
So if you're going to eat in her class, you're going to clean the class for the rest of next term.
Ja.
So put that food away.
En jy mag share.
Right, can I skip? Okay. Right, another example. X to the power of 8 over x to the power of 2. Okay, base is the same and we're dividing. So I'm going to say x to the power of 8 minus 2, which means it's going to be x to the power of 6. Okay, now I want to throw in something different. Not yet. Okay, 2 to the power 3 times 3 to the power of 12 over 2 to the power of 8 times 3 to the power of 8.
I know.
Right, so please do not go and check what is 2 to the power 3 and get that answer. And then 3 to the power of 12 and get that answer. I want you to specifically practice your exponential rules or exponent rules. Okay, so what do you think we're going to do? Yeah? Yes? Yes? Good. Okay, yes. Okay, you can stop there. So basically, what she's saying is, we're going to group those together. That should be, that the bases are the same, ne? So let's group the ones that has got a base of 2 over here. So I'm going to say 2 to the power of, and can you see 2 to the power of 3 divided by 2 to the power of 8? So I'm dividing, so what must I do with exponents? Subtract, okay? So 3 minus 8. No, times, look at the little dot. Now I look at base of 3. I've got 3 to the power of 12 divided by 3 to the power of 8. So that's going to become 3 to the power of 12 minus 8. Okay, so my answer will be 2 to the power of minus 5 times 3 to the power of 4. Any questions there?
I mean, is that the answer? Do you
Yeah.
calculate the basis?
No. You leave it in exponential form. Okay. For those of you that struggle to see what's going on here, if you were to write it out the long method, quickly have a look. At the top, I'm going to delete this because I don't want you to use it. I'm just explaining. 2 to the power of 3 is actually 2 multiplied with itself 3 times. No? So it's actually 2 times 2 times 2.
Which is 8.
Then times 3 to the power of 12. So that means 3 must be multiplied with itself 12 times. So 3, 2, 3, 4, 5, 6, and now my space is up. So do you guys get it, no? 12 times. Yeah?
How would you write 2 to the power of minus 5?
No, I'm going to get to that just now. Okay, then at the bottom, 2 to the power of 8 means 2 multiplied with itself 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Then times, and then 3, 8 times. So 1, 2, 3, 4, and then my space is up again. No? This is what you would have done primary school. And then you cancel out. That 2 with this 2. That 2 with this 2. That one with this one. Can you see no more 2's left at the top?
Yes.
But at the bottom, how many 2's? 1, 2, 3, 4, 5. So at the bottom, I will have 2 to the power of 5. Nay. Okay, at the top, let's cancel out a 3 with a 3 and a 3 with a 3. 3 midi 3, 3 midi 3, 3 midi 3, 3 midi 3. So then at the top, I'm going to have 4 of those left.
Remember, how do you know that the 3 comes on top of the 2?
That's the thing. That because that 2 to the power of 5 is at the bottom of our fraction, it's a negative. But we're only getting to that later on in the chapter. I wanted you to see how it would work, the long method. That's why we got the exponent rules, to make it much shorter and easier for us. Okay, yeah, your question?
Isn't it because there's more 3s on top and then there's
Yes.
2s?
Yeah.
Remember, how do you know if it's a negative when you do those one on the side? That's the 5, the exponent.
On the right-hand side.
How do you know? Yes, ma'am, there's some on the right-hand side. How do you know that the exponent 5 is negative?
Okay. We're only getting to that later on in the chapter, but I'll quickly explain just for now. But if you don't get it, don't worry about it, because you don't have to understand it right now. We're going to get to that law in 2 lessons. Right? When I move in a fraction, like the 2 to the power of 5 is at the bottom.
Yes, ma'am.
If I move it to the top, the sign of the exponent is going to change. So if I move that to the top, it's going to become 2 to the power of negative 5. That's where this comes from.
Oh, so at this one, that one is actually
It is exactly the same thing, yeah. All right. Because that is actually all over 1, but we don't write over 1. No. Do you now get it?
Yes, ma'am.
Okay. If you don't get it, I'm deleting, so forget about it. You don't have to get it, no? Not yet.
So, ma'am, by that one is actually supposed to be negative 4 on the right-hand side, because then that one is at the bottom.
No. The 3 to the power 4 was at the top. And it stays at the top, so it didn't move. So the sign stays the same. Okay. Right. Any other questions?
At least it moves, then it would be a negative, right?
If it were to move to the bottom, then yes. Yeah. Okay, you are getting it. All right. Any other questions? Yeah? Okay. Let's do one more. Last one. I know you guys are tired. X to the power 4, y to the power 2 over x, y to the power of 3. Now, you could have just cancelled out, no? Okay. So if we cancel out, let's do it like that this time. If I remember, in order for you to cancel out, just a little heads up, we must have one term at the top, one term at the bottom, no? So if there was a plus or a minus in between, would we then be able to cancel out?
Yes, ma'am.
Yeah, because a plus or a minus is where we cut terms, no? So then it would be more than one term, and then we're not allowed to cancel. Okay, right, so let's see. At the top, I've got x to the power of 4, and at the bottom, I've got x. So what can I take away? Only one of those x's. Okay, so I take a x at the bottom, and then I take a x at the top. Now, they were 4, so now it's going to become 3, right? Let's look at the y's. Y to the power of 2 and y to the power of 3. I'm going to take y to the power of 2. Yes. So I can take that whole one, y to the power of 2. But at the bottom, I can only take y to the power of 2. So which means there's going to be a y left. Okay. Now.
Ma'am, when you cross out, ma'am, you always start by the larger number.
What do you mean when you decide how much you are allowed to take?
Yes, ma'am, you start.
Okay. You can only take the lowest exponent.
Oh, okay.
I can't take more than what I actually have. So if I wanted to take out y to the power 3, I was able to take it at the bottom. But at the top, if I've only got 2, how can I give you 3? No. So you can't take more than what you have. So always take the lowest exponent. Okay.
Ma'am, but what if the one has one higher and the other one has like if for example, ma'am, the y at the top was
Yeah.
the 5, ma'am,
Yeah.
and then the x here at the bottom was You say it was
Remember, but x and y has got different bases.
so they
So
will
that,
mix now.
no. Stay, the same bases stay together, no? Yeah. Okay, right, so let's just rewrite once we've cancelled out what's left at the top. At the top, I've got x to the power of 3. That y to the power of 2 was taken out completely. At the bottom, the x was taken out completely, but only left with y to the power of 1. Do I have to write the 1? Don't have to. Okay, so that will then be my final answer. Okay. Any? No, it wouldn't be wrong. Okay, good. So can I give you hope? Not can I give you homework. I am going to give you homework. Okay, right. So homework. Okay, so homework is going to be on page 59. Yes? 9 activities. Hi, sis, ek is nie so wreed nie. I quickly want to check something, sorry. Wait. I'll check it on my phone. I can't remember the numbers now. Hey, you guys at the back. But it's not the whole one. I just quickly want to narrow it down for you guys. No, I want to narrow it down. Hold on. I just can't remember which numbers. So let me just quickly check in.
Number 1.
No. Oh, die sign is regtig swak hierso. I know number 2 is 1 up until 6 and then 10. Just give me time, it's loading.
These, I think, I don't know. Yeah. You won't be qualified for that.
Okay, there we go. Okay, so we are doing 1A, but only number 1 and 2. Then at B, we're going to do number 1 up until 6 and then 10. So at B, you're going to do 1, 2, 3, 4, 5, 6, and then we skip 7, 8, 9. No? And then we do 10. Does everyone understand?
Yes, ma'am.
Good. And that is it. You guys can then get started on that. I just want to pause or stop the recording and then send it. I'm going to send it on the group so that if you maybe want to go have a look again when you do the homework, you've got the link. Okay.
Thank you, ma'am.
Pleasure.